Hi everyone. In this video, we'll see what is buoyancy and the center of buoyancy. Before understanding this buoyancy, I'll take one example. Okay, you take an empty water bottle with its lid closed. Uh, Try to immerse that water bottle in a bucket full of water. So when you want to immerse that, okay, when you immerse that water bottle inside the water, moment you leave your hand, that water bottle will comes to the surface. Why actually that is happening? Let me take one more example. Okay, uh, you take a ship or an huge vessel which floats in the water. What made that ship to float in the water? The next one is you take a stone, just put it on the bucket full of water, that stone sinks. So such a huge ship will float on the water, but a small stone will sink to the bottom. Why? For all this, we have an answer, that is because of buoyancy. Then what exactly the buoyancy is? When a body is immersed in a fluid, either fully or partially, it is subjected to an upward force which tends to lift the body. This tendency of immersed body is known as buoyancy. The force tending to lift up the body is known as buoyant force. So it is clear now, there is some upward force which is creating. Okay, that upward force is nothing but an net force which is exerted by the fluid on the immersed body. That immersed body might be an fully immersed or partially immersed. So let me take a sketch by I'll explain this by taking a sketch. You consider a free surface. You consider a body which is immersed in a fluid. Okay, this is fluid of specific weight gamma. Correct. The upper surface of the body is at a distance of h1 from the free surface of water. The bottom surface is at a distance h2 from the free surface of water. Let me take a cross-sectional area of this body as A. Okay, as we know that the pressure increases as the body will going downwards in the water, this upper surface and the bottom surface will be having the different pressures. The upper pressure force will be created, will be downward, which is given by P1 multiplied by area, pressure force. For this surface, I'll take it as 1. For the bottom surface, the pressure force will be P2 multiplied by area. Okay, where P1 and P2 are the pressure force at the top and the bottom surfaces respectively. Then what is the hydrostatic pressure force will be created at the top is P1 into area. But we know that what is P1? P1 is the hydrostatic pressure which is given by density of the fluid multiplied by the depth of immersion. What is the depth at the top? That is H1. This multiplied by area. This is hydrostatic force at top. Similarly, hydrostatic force at the bottom is given by P2. P2 can be written as density multiplied by the distance H2 into what? Area. Now, one force is acting in the downward direction, another force is acting in the upward direction, correct? The net force, we'll calculate the net force now. What is net force? It is P2A minus P1, correct? That is upward positive, downward negative. You substitute, I'll write it like this. This gamma into H2 into A minus gamma into H1 into A. Take out the gamma outside. What is remaining? H2 minus of H1 multiplied by area. Correct. What is H2 minus of H1 here? So H2 minus of H1 is nothing but the height of this immersed body. Okay. This height multiplied by the cross-sectional area of this body is nothing but, this is nothing but volume. Volume of what? The body. Correct. So the density multiplied by the volume of the body. This net force is nothing but the force of buoyancy or the buoyant force. It is usually denoted by capital F suffix B. correct? This is the volume of the body. But this volume of the body you observe here. So once you immerse this body in the fluid, this amount of the fluid will be displaced by this body, correct? So therefore, this volume of the body is nothing but the volume of what? Displaced fluid. The volume of what? Displaced fluid. So therefore, buoyant force you obtain by buoyant force is equal to specific weight of the liquid, which is body is immersed, that multiplied by volume of the body or volume of the displaced fluid by the body. So this is your density, that multiplied by volume, you'll get the weight only. Therefore, buoyant force, which is equal to weight of displaced fluid. Okay, so this is your buoyant force. Buoyant force is nothing but weight of the displaced fluid. This is for completely immersed body in one fluid. Now let me take one more case where we have the body is immersed in liquid of different densities. The upward, the specific weight, I'll take it as gamma 1. Here I'll take it as gamma 2. Okay, this is the volume which is immersed in the liquid 1. I'll take it as V1. This volume which is immersed in a fluid, that is second fluid, will be taken as what? V2. Now the buoyancy force will be written as that specific weight of first liquid multiplied by volume of the body in that liquid 1 plus specific weight of the liquid 2 and the volume of that immersed body in the liquid 2. Like this, you can calculate the buoyant force. Okay. In the same way, let me take the floating body. See, only that is the partially immersion. Okay, this is the free surface of the fluid. So only this much of volume is immersed in the liquid of specific weight gamma, correct? So this is here. This is what? Fluid. Only the certain portion will be immersed in this. So you have to take this, I'll take it as the volume of immersed portion of the body. Now the buoyant force in this case will be given by the gamma of the liquid multiplied by the volume of immersed portion. Why we consider only the immersed portion? Because this is air. Usually the density of air is neglected. Therefore, I'll consider only the density of the fluid multiplied volume of the immersed portion. This is how you can calculate the buoyancy force in the three different conditions. One, it is completely immersed. The second condition, it is immersed in interface between the two liquids. The third case is when it is partially immersed or in the floating condition. Okay, so body, when the body has to be float, means say it has to develop an equilibrium. So when this buoyancy force, the net direction will be always acting upwards. Okay, so let me tell you this, the buoyancy force will be upward direction like this. It is always, the buoyancy force is always vertical, and this is your buoyancy force. The net force will be acting on this, will be also the buoyancy force is always acting vertically upwards. Okay, so as I have told here, the buoyancy force, which is nothing but equal to the weight of the displaced fluid. In this case, the body which has to be float means it has to be develop an equilibrium condition, means the weight of the body will be always acting vertically downwards. So when the force of buoyancy, when it is equal to the weight of the body, then we can say the body will float. Okay, so this usually it is called as principle of flotation. What exactly is the weight of the body floating in a fluid is equal to the buoyant force, which in turn is equal to the weight of the fluid displaced by the body. Okay, body has to be float means the buoyancy force should be equal to the weight of the body. Then you can say the body will float. If this buoyancy force Okay, if this buoyancy force, if it is greater than the weight of the body, then the body will come to the top. If the buoyancy force is less than the weight of the body, that body will immerse, or that body will sink to the bottom. Okay, this is all about the buoyancy force. Now we'll see what is center of buoyancy. I've told how to calculate the magnitude of the buoyancy force. Okay. Now let me tell you where exactly the buoyancy force is acting, because the forces will be having the different characteristics like the magnitude, direction, point of application, where exactly the buoyancy force is acting. That buoyancy force, the point at which the buoyant force is called as center of buoyancy. The point at which the buoyant force is acting is called as center of buoyancy, which is denoted by letter capital B. The B is the point of application of the buoyancy force. It is similar to the G, that is the center of gravity. That center of gravity will, depending upon the weight of the body, the center of buoyancy B will be depending upon the buoyancy force. Okay, so thank you.